Hey guys, it's Mrs. Shevchuk, and today we're going to take a look at dilations. So a dilation is a transformation that's going to either enlarge or reduce a figure by a scale factor relative to a specific center point. And that point that we use is called the center of dilation. For the examples we're working with today, our center of dilation will be the origin. But one thing I want to make sure we point out is that the scale factor, we use the letter K to stand for that scale factor. And if we have a K value that is greater than 1, we're going to end up with an enlargement. If we have a K value or a scale factor that's between 0 and 1, so greater than 0 but less than 1, that's going to be a reduction. So it's going to get smaller. And I'll just jot that here quick. That smaller enlargement obviously is getting bigger. And then if we have a scale factor equal to 1, it's going to stay exactly the same, and they'll be congruent figures. So that's something to think about as we're working today. So our first example is going to have us graph a dilation, and they want us to take triangle ABC and perform a dilation with a scale factor of 2. So what that means is that our image is going to be enlarged. And I know that because my scale factor of 2 tells me everything's going to be twice as big. And so the way that I would start this is I start listing out each of the coordinates, and I see that A is at -2, 1, B is at -4, 5, and C is at 3, 2. And so if I'm enlarging, or if I'm, dilating by a scale factor of 2, what that means is I'm taking each of these coordinates and multiplying both the x and the y by 2. So like in coordinate notation, we would say xy becomes 2x, 2y. So if I have -2, 1, then a prime will be 2 times -2, so that's -4, and 1 times 2 is 2. For B prime, I'm going to double each of these, and I get -8, 10. And C prime, if I double 3 and 2, I get 6 and 4. Then I'm going to go ahead and graph those so that I can see what my image looks like. So I'm going over 6, up 4. There's my C prime, my -8, 10, way over here. There's my B prime, and A prime is at -4, 2. Which is right here. And then when I carefully connect those, I will end up with my image. And remember that we want to show that it's our image by making sure to include these prime symbols on each of these so we can distinguish between our original figure right here and our image. So there's our first dilation. All right, let's take a look at another example. This one says triangle JKL is going to be dilated with a scale factor of 1/2. What that means is that each of our x and y coordinates will become half the size of what they are on our pre-image. All right, so let's start by listing those out. I know they're up above, but I like to kind of write them out on the side here. So J started at 3, 8, K was at 10, 6, and L was at 8, 2. And now when we dilate by a scale factor of 1/2, we're really taking each of those and multiplying by 1/2, or you could say divide by 2, and you're going to get your J prime, K prime, and L prime, and those will be at the following. So we're going to go half of 3, or 3 divided by 2, that's 1.5. Half of 8 is 4. Half of 10 is 5. Half of 6 is 3. Half of 8 is 4. Half of 2 is 1. And so now those 3 points are the ones we're going to be putting on our graph. So J goes to 1.5, 4. So I'm going to go over 1.5 and then up 4. 1, 2, 3, 4. And I will place my point right there. There's J prime. K prime is at 5, 3. Right there. And L prime is at 4, 1. And when we connect those, we will have our image, right? And if we were looking at each of these side lengths, my original KL and my copy of KL, this is going to be half the length of what our original was. JL will be half the length of what our original was, and JK will be half the length of what our original was, because our scale factor was 1/2 in this example, so everything got half the size. And the final example we're going to look at is one where we're given an image and its pre-image, and we have to describe the dilation, like what happened to it, right? So the first thing we have to look at is, well, did it get bigger or smaller? And so we want to start by identifying which one is our pre-image. And I can see here that trapezoid ABCD is our pre-image because it does not have any of those prime symbols next to it. All right, so I'm going to list out the coordinates for ABCD. I've got A at -2, 1, and I've got B at 2, 1, and C shows up at 1, -2, and D is at -1, -2. And then in order to find our rule, one way we can do it, one way we can find our rule is to list out the ordered pairs for list out the ordered pairs for our image, right? So A prime is at -6, 3. B prime is at 6, 3. C prime is at 3, -6, and D prime is at -3, -6. So one of the ways that we can compare these two to figure out what happened is we can look at each of our X and Y coordinates, and I'm going to actually start with B because B looks the nicest to me. These are both positive. So my X value of 2 became 6. My 1 became 3. So I'm asking myself, well, what did I do to get from 2 to 6? Well, I multiplied by 3, right? And I did the same thing here on my Y values. And I can check that with each of these. My X's are always 3 times bigger than my Y's, than my original X's. And so my scale factor ends up being 3. And so when I want to write this rule in coordinate notation, what I'm saying is that every X and Y became 3 times larger than they were in our pre-image. So this is how we would write that we dilated it by a scale factor of 3. And a quick way I can show you this too that we could have checked that is like pick a side length that you can tell the size of, like AB, for example, is 4 units long. So then I can also find that corresponding side on my image and count how many it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and so if the side length on my image is 12 and my pre-image was 4, I can see that it got 3 times bigger. Again, telling me my scale factor is 3 and allowing me to go back and write this rule. And I could have done the same thing with DC. That's 2. D prime C prime is 6. And so again, it got 3 times larger. So just another way you can kind of see that. All right, so that is, in a nutshell, what dilations are all about. Thanks for watching.